Lift your hand. You just decided, right? You thought, lift, and you lifted. Wrong. Your brain started preparing to lift that hand half a second before you knew you were going to do it. In 1979, a quiet neurosurgeon in San Francisco set up an experiment to find out exactly when now happens. 4 years later, his result detonated 2,500 years of philosophy. This is the story of the simplest experiment that changed how we think about thinking. For 2,500 years, philosophers argued about free will. Plato, Descartes, Spinoza, Sartre. They all had opinions. None of them had data. In the 1960s, 2 German researchers named Hans Kornhuber and Ludwig Dicke discovered something with new EEG technology. Before any voluntary movement, the brain shows a slow electrical buildup. They called it the readiness potential. The brain was preparing, but preparing before consciousness or after? Nobody had asked. Enter Benjamin Libet, 64 years old. Neurosurgeon at UCSF. Quiet, careful, modest. A practicing Catholic who believed in moral responsibility. Free will was important to him. He asked a question nobody had thought of. When exactly does conscious will occur, relative to the readiness potential? His setup was almost embarrassingly simple. A subject sat in a chair, EEG cap on their scalp. In front of them, a small dot moving in a slow circle on an oscilloscope, like a clock hand, completing 1 revolution every 2.5 seconds. The instructions: flex your wrist whenever you want. No planning, just whenever the urge strikes you, and tell me exactly where the dot was when you first felt the urge to move. That's it. A clock. An EEG. A wrist flick. The world wasn't ready for what he found. Libet ran the experiment dozens of times. Different subjects. Different days. Same result every time. The wrist flick happened at time 0. The conscious decision, the moment subject said, "Now I want to flex," happened about 200 milliseconds before that, about 1/5 of a second. But the readiness potential? The brain started preparing to move. Then, 1/3 of a second later, you became aware of wanting to move. Then, 2/10 of a second after that, your wrist actually flicked. The order is not what you think. It is not. I decide. Then I move. It is, my brain prepares, then I become aware. Then I move. You are not the author. You are the audience. In 1983, Libet published his paper in the journal Brain. The neuroscience community was stunned. Some celebrated, some attacked. Philosophy departments started teaching neuroscience. And Benjamin Libet, Catholic, modest, careful, went on the offensive to save free will from his own data. Here's what most people don't know about Libet. He believed in free will. He went to Mass every Sunday. He thought moral responsibility was real. He didn't want his data to disprove choice. So he found a loophole in his own experiment. Yes, the brain prepares before you're aware. Yes, the readiness potential precedes the conscious decision. But there's still that 200 milliseconds between when you become aware and when you actually move. In that gap, Libet argued, you have power. Power to stop. He called it free, won't. He even ran a follow-up experiment. He told subjects, prepare to flex, but at the last second, don't. The readiness potential built up, just like before. Then, when the veto fired, the readiness potential crashed back to baseline. The brain was ready. Consciousness said, no. The action stopped. For Libet, this was enough. He wrote, in his last book, we have not free will, but free won't. It's not a theory of free choice. It's a theory of free veto. You are not the author of your actions, but you are the editor. The brain proposes, consciousness disposes, for the next 24 years, Until his death in 2007, Libet defended this position. He never wavered. But the experiments kept getting harder. In 2008, 25 years after Libet's bombshell, a German neuroscientist named John Dylan Haynes pushed it further. Haynes used fMRI, the brain scanner that maps blood flow. He put subjects in the machine, asked them to press a button, left or right, whenever they felt like it. He trained a computer to recognize the brain activity patterns that preceded left versus right. The result was almost unbelievable. Up to 10 seconds before the subjects pressed the button, before they were conscious of having decided. The computer could predict, with above-chance accuracy, which button they would press. 10 seconds. If you'd asked the subjects, "Have you decided yet?" they would have said no. The decision would feel spontaneous to them, made in the moment they felt it. But the brain, the unconscious, biological brain, had already tilted. The scales had been weighted in one direction, seconds before the conscious mind caught up. Haynes was careful. The prediction wasn't perfect. About 60% accuracy on a binary choice. Chance is 50%, so your brain doesn't tell you what you'll choose. It biases the prediction. But the question Libet asked in 1983 had grown teeth. The gap had stretched from milliseconds to seconds. If you could see the unconscious brain, could you predict the conscious decision? For some choices, yes. Not perfectly, but yes. The free won't loophole was looking smaller and smaller. But then, in 2012, the story took a turn nobody expected. A French-American neuroscientist named Schurger was studying the brain's spontaneous activity, the random electrical noise that's always running, even when you're doing nothing. And he had an idea about Libet's readiness potential. What if the readiness potential I sent a preparation signal? What if it's just random noise accumulating to a threshold? Here's how to think about it. Imagine you're flipping a coin. Sometimes you get heads 3 times in a row, sometimes 5 times, sometimes 10, random. Now, imagine you always look at the moments when you've just gotten 5 heads in a row. If you graph those moments, going backward, it'll look like the coin was preparing to land on heads, like a signal was building. But there's no signal. It's just chance and selective attention. Schurger built a mathematical model. He called it a stochastic accumulator. He showed if your brain has random electrical noise that crosses a threshold to trigger movement, and if you only look at the moments after movement, you will see a perfect readiness potential shape. Not because the brain decided, because that's what averaging backward from random does. In 2012, Schurger published his analysis in the journal PNAs. The neuroscience community was startled. Maybe Libet had been wrong about his own experiment. Not wrong that brain activity precedes action, but wrong about what that activity means. The preparation might not be preparation at all. It might be statistics. Your free will might be safer than Libet thought. Just when neuroscientists were rebuilding the case for free will, a Stanford professor of biology and neurology decided to demolish it from a different direction. His name is Robert Sapolsky. In October 2023, he published a 528-page book called Determined: A Science of Life Without Free Will. Sapolsky's argument doesn't even need the Libet experiment. He goes much deeper. When you behave a particular way today, it's because of the determinism that came 1 second before, which was caused by the determinism of the previous minute, which was caused by your hormones this morning, your sleep last night, your stress at work last week, but also the genes you were born with, the womb you developed in, the childhood you had, the culture you grew up in, the accidents that shaped you. Each of those was caused by something before it. Your parents' genes, their childhood, their culture, all the way back, Free will, in Sapolsky's view, is the comforting story we tell about a deterministic chain we cannot escape. Sapolsky devotes 100 pages of determined to the criminal justice implications. If we're not free, what is guilt? What is punishment? He argues for replacing punishment with quarantine, the way we treat a person with a contagious disease, not a person with a moral failing. In 2024, Sapolsky debated philosopher Daniel Dennett, one of the last great defenders of compatibilism. The debate was watched online by hundreds of thousands. Dennett pushed back. Sapolsky pushed back harder. Both men, it turns out, were wrestling with Libet's clock from 1983. So where does this leave us? 43 years after Libet's bombshell, the answer is, we still don't know. Brain activity precedes conscious decisions. That's data. That's not in dispute. But what that activity means is in dispute. Schurger says it might be random noise. Sapolsky says it doesn't matter, even if there's no readiness potential. The entire causal chain of biology says you couldn't have done otherwise. Libet said the brain proposes, but consciousness can veto. Each of those positions has serious neuroscientists defending it today. What the science does tell us with confidence. Your conscious mind is much smaller than you think. The vast majority of what your brain does, it does without you. You walk, you breathe, you swerve a steering wheel before you notice the obstacle. You laugh at a joke before you analyze why it's funny. Most of you is automatic. The slice of you that feels like an I, the narrating, deciding, watching part, is a tiny finishing touch on a deep, ancient biological machine. Libet's experiment didn't disprove free will. It revealed how strange free will is. You are not who you think you are. You are something stranger. You're going to make hundreds of small decisions today. What to eat, when to scroll, whether to be patient with someone who's annoying you, whether to exercise, whether to take a different route home. After watching this, ask yourself something. Not, did I really decide? That's a question that may not have a clean answer in your lifetime. Ask instead, what am I made of? Because the answer is neurons, hormones, memory, genes, childhood, culture, yesterday, the last second, all converging in this moment, in this body into the thing that calls itself I. Libet was a Catholic. He believed in moral responsibility. He died in 2007 still defending the idea that consciousness matters, that you can still say no. Maybe that's enough. Maybe the question isn't, do I have free will? Maybe it's, what is this strange thing that thinks it has free will? That's a question worth carrying with you. Today, tomorrow, the next time you reach for your phone, without quite knowing why. Now zoom out further, past the brain, past the body, past the planet, past the solar system, past the galaxy. Look at the universe itself. In June 2025, the James Webb Space Telescope observed something it shouldn't have observed. 2/3 of the most distant galaxies, 263 of them, are spinning in the same direction. In a symmetrical universe, the ratio should be 50-50. There are two possible explanations for the asymmetry. One is a measurement artifact from Earth's own rotation. The other is much stranger. The other is that our entire observable universe is sitting inside a black hole of a larger universe outside of us. If your brain decides before you do, what decides for the universe?